Hello friends and my dear students, I welcome you all to my channel. This is my first video on mathematics for class 8 following the based on CBSE board. So in this is part 1 video on the first chapter, rational numbers, where I will only discuss the theoretical part of properties, comparisons and standard form of rational numbers with some illustrative examples. In the next video, part 2 and part 3 I will solve the problems of exercise 1A. So this video will be part of the new playlist CBSE Mathematics for class 8 following the textbook of author RS Aggarwal. So in this playlist, all the videos, all the concepts and theory and the problem solving will be based on the textbook of author RS Aggarwal. And once a chapter is complete, I will prepare two sample test papers and solve them, provide the solution video that will evaluate your understanding overall concept of a particular chapter. So if you are new to my channel or not yet subscribed, and if you are watching this video for the first time, I highly strongly request and suggest that you support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's start this video. Okay, so I welcome all the students of class 8 who are studying in the CBSE board. So I'm starting the first chapter, which is the rational numbers, and I will strictly follow the concepts and concepts and problem solving from the textbook of author RS Aggarwal. Okay, so this is part 1 video on the first chapter, rational numbers. In your previous class 6, you have already learned about some types of numbers, that is whole numbers, natural numbers, integers, fractions, and maybe also decimals. So let's start. So let's first do a little bit of discussion, kind of preview of numbers from earlier classes. So you know what are whole numbers. Whole numbers are the numbers 0, 1, 2, 3, 4, 5, 6, 7, and it is endless. It goes on. There are infinite or unlimited number of whole numbers. But remember that whole number also includes the number 0. Now, what are natural numbers? Natural numbers are also known as counting numbers. That when we do a counting of objects in real life, practical life, 1, 2, 3 apples, 4 bananas, 5 bananas, like that. So these are counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, and these numbers are also endless. You have infinite number of natural numbers, and so the whole numbers, the smallest whole number is 0, and there is no largest whole number. Similarly, the smallest natural number is 1, and there is no largest natural number. Now, what are integers? Integers are the whole numbers as well as the negative of the natural numbers. So I am not writing anything on the canvas. I hope you will. These are all concepts that you have already studied in your previous classes. I am just recalling them. So integers are all the natural numbers plus all the integers are the whole numbers plus the negative of the natural numbers. Like it start from for the positive integers, you see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like this, and negative integers are -1, -2, -3, -4, -6. So you must already also be familiar with the number line, where you mark all these numbers on the number line. So you know that 0, the value 0 or integer 0 is marked by the origin. So let me do a little bit of so you have a number line, and you know that the number line is represented by a straight line with pointers at the two ends, meaning it stretches on either end infinitely, and somewhere in the middle we have the point origin O, which origin O which represents the value 0, and then you have all the integers, one positive integers marked at a unit lengths, unit distances from each other on the number line on the right hand side of the origin O. All the numbers on the right hand side of the origin O are positive numbers. You have like this. Similarly, on the left hand side of the origin O, you have all the negative integers. So you have -1, you have -2, you have -3, and it goes on. It goes on. It's endless. So integers are all the natural numbers, that is 1, 2, 3, 4. All the integers are the whole numbers, that is 0, 1, 2, 3, 4, 5, 6, plus the negative of the natural numbers, that is -1, -2, -3, -4. So next you have fractions. Fractions are, what are fractions? We have fractions. Fractions are number of the form a by b, any number that you can write in the form a by b, where a and b are natural numbers, that is they are natural numbers, that is 1, 2, 3, 4, 5, 6, 7, 8, like that. So any numbers, these are fractions. So you have in the notes, you can see 2 by 3, 5 by 3, 11 by 100. These are all fractions because they are all in the form a by b, where a and b are natural numbers. Now I have also mentioned 0 as a fraction, but I don't think 0 will be a fraction because 0 is not a natural number. As per my definition, I have seen different definitions in different books. Some books says that a and b are natural numbers. Some books says that a and b are whole numbers. If a and b are whole numbers, then if this is one definition. Another definition could be, let's say, fraction. Another definition is that a and b, where a and b are whole numbers. Sorry for my bad handwriting, but I hope you will be able to make it out what I am writing. Whole numbers, and b should not be equal to 0. So this is another definition of definition that you will find in some textbook fractions. A and b, a by b, any number in the form a by b, where b is not 0, b is a non-zero whole number, and a is a whole number. So as per the definition 2, if I take a equals to 0, because 0 is a whole number, the whole fraction becomes 0. So as per definition 2, 0 can be a fraction. But as per definition 1, which is also there in some textbooks, a by b, where a and b are natural numbers, you cannot have 0 as a fraction. Anyway, so this kind of you have fractions. Then you have decimals, where you have the decimal point, and the decimal part. This is the decimal part, and this is the integer part. So let's say 3.4. These are all decimal numbers. Now you know the decimal numbers and fractions can be decimal number can be converted into a fraction, and the fraction can be converted into a decimal number. So all these things you have already studied in the previous class: addition, subtraction, multiplication, division of integers, fractions, natural numbers, and whole numbers. I will not discuss all those things in details. Maybe I will start also doing discussion of mathematics for class 6. If I do so, I will let you know. Then you can refer those videos from class 6 playlist if you want to revise your concept. Anyway, now let's come to rational numbers. Now I think you have also studied rational number in class 6. I'm not sure, but anyway, so what is a rational number? Any number of the form p by q, where p and q are integers and q not equals to 0. So rational number, I mean short writing, I will be referring rational numbers as Rn. So I will abbreviate rational numbers as Rn as and when necessary. So whenever I write Rn, you will understand that I mean rational numbers. So what are rational numbers? Rational numbers are any number of the form p by q, where p and q uh, are integers, are integers, are integers, and q must not be equal to 0, and q is not equal to 0. So you can see some examples of rational numbers in the notes. 1 by minus 4, minus 2 by 3 is 0. 0 is also a rational number because 0 is also a rational number because I can write 0 as 0 by 1. So 0 by 1 is in the form p by q, as both 0 and 1 are integers. Similarly, all integers, you take any integers that can be written in the form of rational numbers. Let's say minus 3. It is any integers you can always write. So I can write minus 3 as minus 3 by 1. I can always put denominator 1 with any integers. So to write it in the form of a rational number. Now I hope you also know. This is rational numbers. Now, what are positive rational numbers? Now you can see in the notes that I have mentioned some letters. W is the letter W is used to denote all the numbers, all the whole numbers. Now you might not have studied sets. There is a concept of sets. Maybe you will learn in some higher class, or definitely in class 11 and 12. So what is a set? A set is a collection of set. A set is what is a set? A set, a collection of numbers or any objects. Let's say collection of numbers. You write the collection of numbers in this curly brace. So if I write 3, 6, 9, let's say 12. So this is the collection of all multiples of 3 which are less than equal to 12. So we write set like this. We write a collection of numbers separated by comma with this curly brace. This is the opening curly brace and this is the closing curly brace. Inside a curly brace, opening and closing curly brace, we write some numbers separated by comma. So this denotes this whole thing denotes a set. So we often in your higher class you will study that so we can consider the whole numbers, all the collection of whole numbers as a set, and we denote that set. A set is denoted by a capital letter. So the set of whole numbers is denoted by the capital letter W. We write it as like this: 0, 1, 2, 3, 4, 5. It will go on, and since we cannot write all the it is not possible to write all the whole numbers. So what we do is at the end we write 3 dot, meaning this set the numbers it is an endless, it is an infinite collection of numbers. So it will go on. There is on the right hand side there are much more infinite number of numbers, and be like this. So similarly, let's say the number Z, the letter Z is used to denote the collection of integers. But how do we write the collection of integers? We write like this. Since let's say we have the 0 and then we have the positive integers 1, 2, 3, 4, 5, and to denote that these numbers is endless and it has infinite, there are infinite number of more numbers on the right hand side, we denote with 3 dot and we close it. Similarly, on the left hand side we have -1 and -2, and to denote that there are many more negative integers less than -2 on the left hand side, we denote it by 3 dot. So anyway these though these sets and concepts are not in your syllabus, I thought to give it a little overview. Now back to the point. So I was discussing rational numbers. So rational number is a number, any number that you can write in the form p by q, where p and q are integers and q is not equal to 0. Q should not be 0. Now, okay. So I was saying, so integers is denoted by the collection of integers is denoted by the letter Z. The collection of whole numbers is denoted by the letter W. Similarly, the collection of natural numbers, is denoted by the letter N, and we have 1, 2, 3 like this. Fractions I don't know, decimals I don't know. Rational numbers, all the rational, the letter Q is used to denote the collection of rational numbers or the set of rational numbers. Now you must also, so regarding rational numbers, there is no smallest rational numbers. Also for integers, you know that there is no smallest rational numbers, because on the number line to the left hand side of origin there are infinite number of negative numbers which are less than 0. So there is no smallest integer and there is no largest integer, but the smallest natural number is 1 and the smallest whole number is 0. Integers also, as for regarding integers, know that we also denote, so this is rational numbers, the letter Q is used to denote the collection of rational numbers. Now Z plus is also used to denote positive integers. Positive integers. The set or the collection of positive integers is denoted by Z plus, and Z minus is used to represent or denote the set of negative integers. Now I hope you know or you are aware of the fact that integer 0 is neither positive nor a negative. It is not a negative number, it is not a positive number. You must be aware of this. 0 is neither positive nor negative. So what are positive integers? What are positive integers? The positive integers are starting from 1, 2, 3, 4 and it goes on. What are negative integers? Minus 1, comma, minus 2, comma, minus 3 and it goes on to the left hand side. There are endless negative integers, there are endless positive integers. Okay. Now also you must be aware of the fact that all whole numbers and natural numbers are integers. Also all natural numbers are whole numbers, but all whole numbers are not natural numbers, because 0 is not a natural number. All these little concepts you must be aware of. Similarly, and also note that fractions are always positive. Fractions are always positive. If you consider that 0 is not a fraction, then fractions are always positive. Fraction is as per the definition you can see, fraction is a by b, where a by b are natural numbers. So you cannot have negative fraction. Fractions are always positive. And fractions also includes fractions also includes the positive integers and of course the natural numbers. Okay. Now we discussed rational number. So we have now positive rational numbers and negative rational numbers. What are positive rational numbers? The collection of positive what are positive rational numbers? The collection of positive rational numbers is denoted by Q plus. The letter Q is used to denote the collection of all rational numbers. The letter Q plus is used to denote only positive rational numbers. Now what are positive rational numbers? Positive rational numbers are those rational numbers, basically it says positive. Now a rational number has two parts, P by Q, P and Q. Now so a rational number is of the form P by Q. Now when this whole P by Q will be positive, I mean short, using some short notations, instead of writing the word positive I am writing this. It will be positive if P greater than 0 and Q greater than 0. If both the P is known as the U. So in a rational number or fraction, you know we have a numerator and the denominator. In the fraction, if you consider P by Q as a fraction or a rational number, P is the numerator and Q is the denominator. So if both the numerator and the denominator are greater than 0, then we say then the rational number is positive. That is, or there is another condition, or P less than 0 and Q less than 0. That is, when these two conditions are satisfied, that is both P and Q are greater than 0 or both Q and P and Q are less than 0, then the rational number P by Q is a positive rational number. You can consider it as in other way, like if both P and Q have same sign. By sign I mean positive or negative. If P is when P and Q both are positive or both are negative, it means that they both have the same sign. So if P and Q have the same sign, the rational number P by Q will be positive. Similarly, we have negative rational numbers, which is denoted by the letter Q minus. These are negative rational numbers. Now, while I am speaking, you can see the notes and see some examples. You can take a screenshot of my notes if you think it will be beneficial to you. You can see the examples. I have written some examples for all the kinds of numbers, the positive rational numbers, negative rational numbers, rational numbers. So what are negative rational numbers? Negative rational numbers are denoted, the collection of negative rational numbers are denoted by the letter Q minus. So P by Q, this rational number will be negative if P greater than 0 and Q less than 0, or P less than 0 and Q greater than 0. Now what does it mean if P greater than 0 and Q less than 0? P greater than 0 means P is positive integers. Q less than 0 means Q is a negative integers. So P and Q are having opposite sign. And what does it mean when I say P less than 0? Means P is negative integers and Q greater than 0 means Q is positive integers. So here also P and Q are having opposite sign. So a rational number will be negative if the numerator and the denominator are having opposite sign. Okay. So I hope it's clear what are positive rational numbers and negative rational numbers. You can take screenshot of my notes on the left hand side regarding the examples. Okay. Now let's see what do we have. We have next is the standard form of a rational number. What is the standard form of a rational number? Now, a rational number is said to be in standard form if first of all the denominator is positive, that is Q is greater than 0, and there is no common divisor of P and Q other than 1, that is P and Q are co-prime to each other. Now P and Q in standard form if Q is greater than 0, there are two conditions, there are two criteria rather. One is Q has to be greater than 0, and another one is P and Q are co-prime to each other. Now when two integers, maybe you are aware of the word co-prime, two integers or two natural numbers A, my machine is running slow, I have no idea why, A and B integers, two integers A and B are co-prime if HCF, highest common factor between the numbers A and B, is equal to 1, that is they do not have any common divisor other than 1, like 2 and 3 are co-primes. You take any two primes, they are co-primes. Let's say 7 and 9, they are co-prime. There is no common divisor between 7 and 9, even though 9 is not a prime number. So any two numbers, integers, which do not have a common divisor other than 1, they are known as co-prime to each other. So in this we must have P and Q co-prime, which actually means that HCF of P and Q has to be equal to 1. HCF of P and Q equals to 1 means there is no common divisor between P and Q other than 1. So any rational number P by Q will be in standard form if these two conditions 1 and 2 are satisfied. the denominator has to be greater than 0, denominator is q, and the p and q should not have any common divisor, that is the HCF of p and q should be 1. You can see my notes and see the examples. I am not writing any examples. Okay, so this is about any rational number in standard form. Now a question can be, how will you convert a given rational number to standard form? Let's say I have a rational number 2 by 3. Now if any given rational number is not already in standard form, it will definitely mean that there is a common divisor between 2 and 3 which is not equal to 1. And if a given rational number, if in a given rational number we see there is no common divisor between p and q, that is the HCF of p and q is 1, then it is already in the standard form. In this example 2 by 3, this is already in standard form because the HCF, we can see clearly that HCF of 2 and 3 is equal to 1. So 2 by 3 is in standard form. Now let's say 4 by 6. This is not in standard form because we know that HCF of 4 and 6 is 2, which is not equal to 1. So is not in standard form. Also note that 2 by minus 3 is not in standard form as minus 3 is less than 0. This is q. Q cannot be less than 0. Q should be greater than 0. Okay. What else? Okay, so these are not in standard form. So how do you convert a rational number which is not in standard form to standard form? Now, how do I? So 2 by minus 3 is not in standard form. So how will I convert this to standard form? I can see that the p and q are having HCF. Now, if you just ignore the signs of the p and q, if you ignore the signs of p and q, now first of all, you see that the denominator, the q, is less than 0. First, you have to make it positive. How do you make a denominator positive and keeping the rational number unchanged, that is same? You just multiply both the numerator and the denominator by minus 1. This is how, if the denominator of any rational number is minus 1, and if you want to make it positive but the rational number should remain same, this is how do it. You just multiply both the numerator and the denominator with minus 1, and this become minus 2 by 3. It is very simple. If you have any rational number where only the denominator is negative and you want to make the denominator positive, just make the denominator positive and the numerator negative, as simple as that. Okay, now how do I convert this rational number 4 by 6 into standard form? I can see that I will divide this is equal to, okay, now before discussing this, I have to discuss the three properties of rational numbers. So I will, how do we convert a rational number which is not in standard form to standard form? To discuss that, I need to first discuss the three properties of rational numbers. So let's first discuss the three properties of rational numbers first, then I will come back to this topic later on. Okay. The first property says that if you have a rational number p by q, you have a rational number p by q. This rational number, this rational number will, if I multiply both the numerator and the denominator by some non-zero integer, you cannot multiply by 0. Any non-zero integer, if I multiply both the numerator, this is I am multiplying the numerator with m, where m is a non-zero integer, and the denominator with the same number, with the same non-zero integer, these two rational numbers will be equal. Where where m is not equal to 0. So given a rational number, I can always multiply both the numerator and the denominator by some non-zero number, and the rational number will remain unchanged, meaning these two rational numbers will be same. Now for these kind of rational numbers where one rational number, this rational number is obtained from this rational number by multiplying a non-zero integer with both the numerator and the denominator. So these kind of rational numbers, p by q, and this is also also written as pm by qm. I hope you are aware of the fact that you have already done algebra. You have already done algebra in class 7. So a into b in terms of algebra is written as ab. By ab we mean that a into b. Okay. So p into m by divided by q into m is basically pm by qm. So these two rational numbers, p by q and pm by qm, are known as equivalent rational numbers. Equivalent rational numbers. Why equivalent rational numbers? Because their value is same. P by q, the value of p by q and the value of pm by qm is same, because you can clearly see that I can cancel out m and m from the numerator and the denominator from the right hand side rational number, that is pm by qm. But yet they looks different. That is why they are called equivalent rational numbers. They are equal, that is their value is same. But in the form, if you consider the form p by q, the p and q are different in the two rational numbers, but their value is same. They are equal. So these kind of rational numbers where one rational number is obtained from another rational numbers by multiplying both the numerator and the denominator with some non-zero integer like m, they are known as equivalent rational numbers. Now two rational numbers can be equivalent, three rational numbers can be equivalent, 4, 5, 6, any number of rational numbers can be equivalent. So while I am discussing and speaking, please take a note, please see also the notes, you will see some examples. So this was property number 1, where it says that if you are given a rational number p by q, you can always multiply both the numerator and the denominator with some non-zero integer m, and the rational number remains unchanged, that is its value remains the same. Okay. Similarly, if you have a rational number p by q, this was property 1. If you have a rational number p by q, and if you see that the common divisor of p and q is not equal to 1, that is p and q have a common divisor. So let's say p and q, and let HCF, that is the highest common factor of p and q, be equal to m, and m is not equal to 1. Let's say p by q is such a rational number such that the HCF of p and q, let's say we are denoting saying that HCF of p and q be equal to m, and where m is not equal to 1, which means that p and q are not co-prime, that is they have a common divisor which is not equal to 1. If p by q is such a rational number, then we can always write p by q equal to, we can always divide the numerator and the denominator by m, and the rational number remains the same. So p by q will be equal to p divided by m divided by q divided by m, where m is the HCF of p and q and m is not equal to 1. So this is property number 2. Property number 3 says that if you have two rational numbers, let's say a by b is the rational number and c by d is another rational number, and if you know that they are equal, if this equality is true, that is A by B is equal to C by D, then this implies if you do cross multiplication, cross multiplication is indicated with this symbol. That is, if you multiply A and D and multiply B and C, the value of A into D will be equal to B into C. That is, A into D will be equal to B into C. So if two rational numbers are equal, that is, if you have A by B equals to C by D, this will imply A into D will be equal to B into C. Also, if you have something like, if you have A into D, something like this, A into D is equal to B into C, this will also imply that A by B is equal to C by D. Now, if you consider this as result 1 and this as result 2, if you combine these two, combining 1 and 2, I hope you are aware of this symbol. This means that now I hope you know this implies what this symbol implies means. Where will I say? Okay, so when you have something like this, LHS, whatever this LHS is, implies RHS. This basically means that if LHS is true, it will we can say that RHS is true. If LHS is true, we will say that RHS is true. Now, if you have something like this, that if you have something like this, that RHS implies LHS. Now, what are these LHS and RHS? LHS and RHS is normally some result or some result. It could be some equality equation or anything else. It's some result. So if LHS is result, so if it is true, then the result RHS will be true. The first one, the meaning of the first one is that if LHS, the result LHS, whatever that result is, if LHS is true, then we can say that RHS is true. And the second one says that if RHS is true, then LHS is true. If you combine this, we write it combining this, we write double implication. You have arrowhead on both sides and we write this. That is, this thing, double implication means that LHS, if LHS is true, then it will we can say that RHS is true, and if RHS is true, we can say that LHS is true. So when I am combining in this property 3, when I am combining 1 and 2, I can say that A by, so in this property number 3, you can consider this as the LHS result, this as the LHS result, and this as the RHS result. And you can see this over here, this is also the RHS result. Sorry, what is happening? This is the RHS result, and this is the LHS result. So based on the concept that I discussed, LHS implies RHS, RHS implies LHS, this will mean that LHS double implies, we will have a double implication between LHS and RHS. Similarly, for the property 3, we can have A by B. If A by B rational number is equal to C by D, we will have a double implication that A into D equals to B into C. That is, this result will imply this result and this result will also imply the left hand side result. That is, if A by B is equal to C by B, then we can say A into D equals to B into C, and if we know that A into D is equal to B into C, then we can say that A by B is equal to C by D. Okay, so basically this property 3 is usually used to verify the equality of two rational numbers. Let's say if you are asked to say that to verify whether 4 by 6 is equal to, let's say, 8 by 12 or not. For example, if you are given two rational numbers like this, and you are asked to verify whether these two rational numbers are equal or not. So you can quickly do a cross multiplication using this property 3. You can quickly do cross multiplication and verify whether 4 into 12 is equal to 6 into 8, and this is indeed true. We can see that 48 equals to 48, this is true, and you will say that 4 by 6 is equal to 8 by 12. So to verify that two rational numbers are equal or not, you can use this cross product result property. Okay, so this was about the three properties of the rational numbers. Okay, now that you know these three properties, especially the 1 and 2, let me come back to the point where I was discussing how do you convert a rational number which is not in the standard form. Let's say 4 by 12. This is a rational number not in standard form. How do you convert it into a standard form? So we can clearly see, first you have to find out what is the HCF of the numerator and the denominator. We know that HCF of 4 and 12 is equal to 4. So what we do is we divide. We know that any rational number we can divide both the numerator and the denominator by the HCF, and the rational number remains the same. So I will divide both the numerator and the denominator by 4, as 4 is the HCF of the numerator and the denominator. And what do I get? I get 4 divided by 4 divided by 12 divided by 4, which is 1 divided by 3. This is in standard form. This is in standard form. So this is the concept. But before that, before applying this concept, if you are given a rational number which is not in standard form, and you see that the numerator and the denominator, their HCF is not equal to 1, then you just divide both the numerator and the denominator by their HCF. But before that, you must make the denominator positive. So let's say we have, let's say, 3 by minus 6. First of all, I will this rational number 3 by minus 6 is not in standard form. Is not in standard form because we see the denominator is negative, one thing, and second thing, we also see that the HCF of 3 and minus 6 HCF, I hope this is now the denominator is negative, so by that we can clearly say that it is not in standard form. Now, so first of all, the first step, but for this kind of rational numbers where the denominator is negative, we first have to make the denominator positive. So we just multiply both the numerator. We multiply both the numerator and the denominator with minus 1. So in any rational number, if you see denominator is negative, and to make the denominator positive, you just multiply both the numerator and the denominator with minus 1. Then the denominator will become positive, and the numerator, it may be positive or it may be negative, does not matter. What matters is a rational number. To make it in standard form, the denominator has to be positive. So this becomes minus 3 by 6. Now minus 3 by 6, this is also not in standard form. This is also not in standard form because we see that the HCF, of HCF of, if you ignore the sign, we can see that the HCF of 3 and 6 is 3, which is not equal to 1. So uh, we can convert this rational number by into its equivalent rational number, or an equivalent rational number, by dividing both the numerator and the denominator by 3. We can do this. Since we can see that ignoring the sign of the numerator and the denominator, the HCF of the numerator and the denominator, ignoring their sign, is not equal to 1. In this case it is 3. So we can always divide both the numerator and the denominator by the HCF. So this is so we have minus 3 divided by 3 is minus 1, and 6 divided by 3 is 2. Now this is in standard form. I hope you got the idea how do you convert a rational number which is not in standard form to a standard form, and how do you convert a rational number, how do you make the denominator of a rational number positive if it is negative. Okay. The next and the final topic is about comparisons of rational numbers. Comparisons of rational numbers. How do you compare two rational numbers? Now so the idea is that you have to compare two rational numbers, that is in terms which is smaller or which is greater, or if they are equal. That is, if they are equal, or if one is smaller than the other, or one is greater than the other. So if we have two rational number p by q and r by s, how do we know that if p by q is equal to r by s, or p by q is less than r by s, or p by q is greater than r by s? So first of all, you must know that if all positive rational numbers, if p by q is a positive rational numbers, if p, so let's try to understand how do we do the comparison step by step. There could be a lot of steps, but don't worry, these are all basic concepts. So if p by q is greater than 0, that is p by q is a positive rational number, and we see that r by s is less than 0, r by s is a negative rational number, this will imply definitely that p by q has to be greater than r by s, because all positive rational numbers are obviously greater than all negative rational numbers. Now it could be other way around, like it could be other way around, it could be opposite, like if p by q is a negative rational number and r by s is a positive rational number, this will obviously imply that p by q is less than r by s. So I just explained in the notes, if you see, it is written all positive rational numbers are greater than 0 and all negative rational numbers are less than 0. This point I have just illustrated with some examples. If you are given two rational numbers p by q and r by s, and if you clearly see that of these two rational numbers, one is positive and one is negative, then definitely the positive rational number will be greater than the negative rational number. This is exactly what I explained in the steps 1 and 2 where I am explaining. Okay. Next, first we have to say this: if in the given two rational numbers, if one is positive and other one is negative, definitely the positive rational number will be greater. Now let's say both the rational numbers p by q and r by s, they are either both positive or both negative. How do we convert them? First of all, you have to convert both these rational numbers to their standard form. So I am assuming that. So in the point number 3 in the notes, you can see convert rational numbers to compare to their rational standard form. So before comparison, you convert both the rational numbers p by q and r by s to their standard form. That is, both the denominators will be positive and there will be no common divisor in both the rational numbers. There will be no common divisor between the denominator and the numerator. Now let's say p by q and r by s are both in standard form. How do we compare? Okay, now it could be the case we have to divide we have to discuss case by case. Let's say in the two rational numbers p by q and r by s, the denominator is same. Let's say the rational numbers are p by q and r by q. So we can see that the denominator of both the rational numbers is same, p by q and r by s. Now, how do we compare these two rational numbers? It is very easy. We just compare the numerators, that is p and r. So we say that we say that the rational number p by q will be greater than the rational number r by q if p is greater than r, and the rational number p by q will be less than the rational number r by q if the numerator p is less than the numerator r. And of course p by q will be equal to r by q if both the numerators are equal. So this is the case where both the rational numbers are already in standard form, and both the rational numbers have same denominator, that is q. Okay. Now what about if the denominators are different? This is where you have to do a little bit of work. So we have two rational numbers, p by q and r by s, and they both are in standard form, that is both q and s are positive, and they are having different denominators, that is q and s are different. How do we compare them? The first step is you find the HCF of the denominators, HCF of q and s. You find LCM. You find the LCM of the denominators of the two rational numbers. LCM of q and s, let's say that be m. Let's say I'm assuming m is the LCM of the two denominators q and s. What next? You convert both the rational numbers p by q and r by s to their equivalent form, so that the denominator is m. That is, I have to convert the rational number p by q to its equivalent form, so that it will be something like p dash by m, where p will be some integer and m will be the denominator, where m is the LCM of q and s. Now how do I get p dash by m from p by q? It is basically, what we do is you have to multiply p with m divided by q. Now it might look complex, but if you do a little bit of thinking, you will clearly understand. If you from the p by q, I want to convert p by q to its equivalent form p dash by m. What is m? M is the LCM of q and s, and p dash will be some integer. Now how do I know m? How do I find p? P dash. P dash will be equal to p into m divided by q. You know m, you know q, you know p. What is m? M is the LCM of q and s. So from this you can always find p dash. P dash is p into m divided by q. Now this might look a little bit of complex, lot of equations, but I think you are already familiar with this, and while you will solve it with the problem, it will come automatically. So do not worry about all these equations and all these algebraic expressions, p into m divided by q. It is very simple if you do a little bit of thinking. So this will be equal to, actually p dash will be p into m divided by q, and this is m. M is the LCM of q and s. Similarly, I have to convert r and s to its equivalent form. Let's say r dash by m. M will be also we have to convert both the rational numbers p by q and r by s to their equivalent form, and both the equivalent form will have the same common denominator, which will be m. And what is m? M is the LCM of Q and S. So from the rational number R by S will be converted to its equivalent form R dash by M. We know M. Now how do I find R dash? It will be similar. R dash will be R into M divided by S. R dash will be R multiplied by M divided by S. Now if you take this becomes R into M divided by S multiplied by M. Okay, now this was all algebraic. I explained it algebraically. Now if you do take a real example, now okay, so you got a P dash. You have converted P by Q to its equivalent form P dash by M, and you have converted the rational number R by S to its equivalent form R dash by M. R dash by M, and what is M? M is the LCM of Q and S. Now we have to convert. We have to compare P dash by M and R dash by M, and here you can see that both the rational numbers P dash by M and R dash by M have same denominator M. You now just have to compare the numerators. That is, this will be greater than this if P dash is greater than R dash, and P dash by M will be less than R dash by M if P dash is less than R dash. Let's take a, now you can even though this all this algebraic explanation might look a little clumsy and not very cluttered or congested, but when I am speaking, while I am discussing, when I am talking, if you take notes, it will be helpful. Now let's quickly do based on this. So these are all the theoretical concepts that I have some examples in the notes, so you can take a screenshot of these notes. It has some examples. You can take screenshots as a future reference to understand the concept. While I am scrolling, you can pause the video and take a screenshot. Okay, so I have discussed the theoretical part. Now mathematics is not theoretical. You have to apply the concept and theory in problem solving. Then only when you do a lot of problem solving, then only, and apply the concepts in solving the problem, only then you understand the concept more clearly, or the concepts will be more crystal clear in your mind the more you solve problems. So let's solve a few problems. I am selecting some problems from exercise 1A, even though I will solve all the problems of exercise 1A in two videos, that is part 2 and part 3. In part 1 probably I will solve exercise problem number 1 to 7, and the remaining problem number 8 to 10 I will do in part 2. So I will solve all the problems of exercise in separate videos. Do not worry about that, but just for the sake of discussion, let's do some little bit of problem solving. Now let's say, how do I express this number in standard form? This number is standard form. Clearly you can see that rational number 24 by minus 64 is not in standard form. First, because the denominator is negative, minus 64 is less than 0, and also we can see that HCF, if you take just the numerical part of the numerator and the denominator, what is, I hope you know that the absolute value, what is absolute value of a number, you just ignore the sign. Absolute value of minus 4 is 4, absolute value of 0 is 0, absolute value of 4 is 4, absolute value of minus 10 is 10, absolute value of 6 is 6. So you find the HCF of the absolute value of the numerator and the denominator, that is 24 and 64, and you will clearly see this is how much. Is it 4? Is it 4? Or is it 8? I guess it is 8. I hope it is 8. The HCF of 24 and 64 is 8. Okay, let's say is it 8? I could be wrong, but let's say the HCF of 24 and 64, clearly 8 divides both 64 and 64, 24 and 64. So HCF is definitely not 1. So both the conditions are violated, that is denominator is less than 0 as well as the HCF of the numerator and the denominator is not equals to 1. So first of all, what is the first step? I will make the denominator positive, that is I will multiply both the numerator and the denominator with -1. I will multiply both the numerator and the denominator with -1. So this becomes -24 by 64. Now the denominator is positive. Now I will divide both the numerator and the denominator with the HCF. What will I do? I will divide both the numerator and the denominator by 8, but by the HCF of the numerator and the denominator, and I hope HCF of 24 and 64 is 8. I could be wrong. Let's assume that the HCF of 24 and 64 is 8. So I will divide both the numerator and the denominator with their HCF, and this is equal to -3 by 8. So this rational number -3 by 8 is now in standard form. So this was a quick example to show how you convert a given rational number to its standard form. Okay. Now let's quickly do another problem to find given two rational numbers which is greater or which is smaller. Now it is given -2 by 9. Let's say what will be, let's do a little bit of fill in the blanks. What will be here? 0. I mean, the fill in the blanks, you can either use the less than operator, greater than operator, or equal to operator. What will be the fill in the blanks? Definitely -2 by 9 is a negative rational number, and all negative rational numbers are always less than 0. So this will be less than 0. Similarly, if you have something like 3 by 8 and you are asked to fill in the blanks with the operators less than, greater than, equal to 0, what will be? It will be greater than, because 3 by 8 is a positive rational number and all positive rational numbers are always greater than 0. So these are two basic examples. Now let's say, take another example. Let's say -1 by 2, fill in the blanks, -1. What will be here? Less than, greater than, or equal to? Definitely equal to will not be there, because -1 by 2 is definitely not equal to -1. Or is it less than or greater than? So the rational numbers are -1 by 2 and -1. So we see that both the rational numbers are already in standard form. That is, the denominator -1 is nothing but -1 by 1. The denominators 2 and 1, they are all positive, and both the rational numbers, the HCF of the numerator and the denominator is 1. Now how do we compare them? We see that the denominators are different, so we find the LCM of the denominators. The LCM of 2 and 1 is obviously 2. So we convert the -half into its equivalent rational numbers. Now I will not go into all these algebraic formula that I have discussed, even though these are the algebraically this is correct, these are the formulas, but it might look little clumsy. It's better to understand with an example. So how do I convert the rational number -half to its equivalent form, so that the denominator is 2? The denominator is already 2, so nothing to do about -1 by 2. The denominator is already 2. Now how do I convert the rational number -1 by 1 to its equivalent rational number, so that the denominator is 2? We see that with what number I have to multiply the denominator, which is 1, to make it 2. That will be 2. So the numerator will also have to be multiplied with the same number 2. In converting -1 by 1 to its equivalent rational form, so that the denominator is 2, I have to make the denominator 2. The denominator is right now 1. How do I convert this rational number -1 by 1 to its equivalent rational number, so that the denominator is 2? How do I do that? I will see that with what number I will multiply the denominator to make it 2. I have 1, so I will multiply with 2. So 1 multiplied by 2 will give 2. So the whatever number, with whatever number I have to multiply the denominator, I will multiply the numerator with the same number, that is 2. So we got finally minus half and minus 2 by 2. Now with these two rational numbers have same denominator 2. Now I will compare the numerators. I can clearly see that minus 1 is greater than minus 2. This will imply that minus half is greater than minus 2 by 2, and this implies minus half, the original rational number was minus half only, and the original rational number of minus 2 by 2 was minus 1. So minus half is greater than minus 1. Let's do another example. Let's say, how do I compare 4 by minus 5 and minus 7 by 10? How do I compare this? Now we can clearly see that the first rational number is not in standard form, but the second rational number is in standard form because the denominator 10 is positive and also the HCF of 7 and 10 is 1. But the first rational number is not in standard form. First, I will convert the first rational number to standard form by multiplying both the numerator and the denominator with minus 1, because the denominator is minus 5 is less than 0. So this remains the same. So this becomes a minus 4 by 5. So now we have to compare minus 4 by 5 and minus 7 by 10. We see that the denominators are different. So we have to find the LCM of the denominators. We have to find LCM of 5 and 10, which is equal to 10. So now we have to convert both these rational numbers to their equivalent form, so that the equivalent form have the denominator 10. How do I convert minus 4 by 5 to its equivalent rational form, so that the equivalent rational form has the denominator 10? I see that I have to multiply 5 with 2 to make it 10. I will multiply it by 2, so I will multiply also the numerator with 2. So this is the equivalent form. Similarly, in the second rational number, the denominator is already 10, so I will not do anything. So minus 7 by 10. So now what are the two rational numbers that I have to compare? It is minus 8 by 10 and minus 7 by 10, and I clearly see that minus 8 is less than minus 7. So this implies that minus 8 by 10 will be less than minus 7 by 10, and this implies minus 8 by 10, the original rational number was minus 4 by 5. This will be less than minus 7 by 10, the original rational number was minus 7 by 10 only. So we get this. So I hope these basic examples will give you a clear idea how do we compare rational numbers. Now in real problems, you might be asked, you will be given more than 2 rational numbers, 3 or 4 or 5 rational numbers, and you will be asked to arrange them in ascending order or descending order. So basically you have to use all these concepts, the concept of comparing 2 rational numbers, to sort them, to arrange them in ascending or descending orders. And while doing so, you will also need to apply the concept of converting a rational number to its standard form. So we will apply all these concepts that we discussed in this video while we will solve the problems from exercise 1A. So the next video, part 2, I will solve the problems from 1 to 7 from exercise 1A, and in another video, part 3, I will solve the remaining problems, that is problem 8 to 10 of exercise 1A. So I hope this video was beneficial to you. If it is, then please like it and share this video with your friends. If you can bring more friends to my channel, it will really help me, because my channel is new and I am really putting a lot of effort to prepare some useful content video for mathematics. I've already started. I have already a playlist, CBSE Maths 7, following the textbook of RS Aggarwal. If you have any brother or sister who is in class, who's studying in Standard 7 and in CBSE board, you can refer my channel, the playlist CBSE Maths 7 RS Aggarwal. So I will soon be starting a new playlist for class 9 and 10 CBSE board, following the textbook of author RS Aggarwal. So if this video was useful, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. And stay tuned for the next videos, where I will solve the problems from 1 to 7 in part 2 and problem 8 to 10 in part 3. So that's it for today's video. Thanks for watching, and until the next video, take care and bye.